So let's start with this one. Jenny plans to spend $360 on tickets to a museum. The museum offers a discount of $5 for each ticket. And in this case, she could actually purchase 4 more tickets by paying an extra $40. So find the original price of each ticket. So of course, we let X be whatever the question is asking for. And in this case, let X dollars be the original price of each ticket. Now, to do this kind of question, we always draw this before and after table. And in this case, it's before what? Before the discount and after the discount. So we have 2 scenarios. Now, what goes on the columns? Okay, you always have this kind of speed times time equals to distance kind of thing. So in other words, you will have one equation, 1 speed times 1 time equals 1 distance. And for another one, you have a second equation with different speed times different times time equals to different distance. But of course, speed times time equals to distance is just an analogy because we don't see that in this situation. Think about it. In this situation, we have a different kind of speed problem. Is ticket price times the number of tickets equals to total amount you spend. Okay, but this can be translated to pretty much all the other quadratic application word problems that we will encounter. Now let's start with the before scenario. What kind of information that we have? We knew that we spent $360 on the tickets, and each ticket originally cost X dollars. So that's all we have. But number of tickets, how do we get that information? Well, number of tickets is just 360 over X, right? Well, obviously, because ticket price times number of tickets equals to this. Okay, so you could back out and find the number of tickets like this. In the beginning, it seems it's such a dumb equation, which doesn't lead to anywhere. But we'll make use of this later. Now, what about the after discount scenario? Well, now with a discount of $5 on each ticket, so this will be my ticket price coming off from X, right? And because I'm paying an extra of $40, this is going to be my new total amount. And again, with this speed time distance thing, just like last time, we could back out and get the new number of tickets, which is this. So the sequence is more like you start from here and then you go to here and then it comes back like that. So now what? Where's the last piece of the puzzle? It's actually right here on the number of tickets. Before and after has a difference of 4 tickets, right? So now we have successfully formulated the equation, so we could continue and find the answer. Now let's back up a little bit. We can start here. Now, because we can purchase 4 more tickets, we could actually write the new number of tickets in terms of the old one, right? Which is like this. So everything is in this sequence, and in this case, every new term, this is in terms of the old one. So now, what is the equation? It will be like this. The speed times time, right? Which would become this equation. And that's still a correct one. And then we could continue the calculation on this. Now let's see if we could apply the same system on this kind of question, okay? So Charlie takes 240 minutes more than Kate to finish typing some manuscripts alone. When they finish the job together, they take 160 minutes. So how much time is required for Kate to finish the job alone? So obviously it's asking for the time for Kate to finish the job alone. So I let T minutes to be that time. Now this time, what is the before and after? Well, we're comparing Charlie and Kate, right? So what about the speed, time, distance in this case? Well, speed is just the typing speed. Time is the time required to finish. And the distance is not distance anymore. It's the number of manuscripts or the amount of work. Which of these boxes could be filled out? Well, because Charles takes 240 minutes more than Kate, and T is Kate, right? So all I could fill out is just these 2 boxes. But then these 2 columns are totally empty. But we need to fill out at least one to get the other one, right? Using the time. So why don't I come up with another variable here? N to be the number of manuscripts. But it doesn't really matter. Later on, it's going to disappear. So now using the speed time distance formula, we could get the speeds like this by going from time, manuscripts, and then to speed like that. But we're not done yet. We still haven't used this 160 minutes for our work. And what is this 160? The 160 is when they finish the job together, when they work together. And when they work together, that means the speeds be added together, not the time though. So we will have an extra row here, and the speed of the together will be the sum of the two speeds. And the time it takes together is specifically given, it's 160 minutes for the same job, that is n manuscripts. And now what? Because this is also a speed time distance kind of thing, we could put them together all in one equation. So we have this equation. Now wait a minute, we have one equation, two unknowns. What do we do? Well, you can factorize out the n here, which eventually cancels out the n. So you're left with only one equation with one unknown. Then you could continue. So this equation is a good one. In fact, you could actually just put all ones in here, and you don't even need to let n be the number of manuscripts, as long as they all are doing the same job. So you just treat it as one single 100% of the job. Now here are some tips. Showing the units may help. For example, if you look at this, the minute here will cancel out each other, so you end up with just the number of manuscripts. So by looking at the units, you know that you're using the right number or not. Another thing is, how do you fill out this table? Sometimes using the horizontal relations. For example, this one, you go from here, here to here, right? That's the horizontal relations to come up with the next box. And for vertical, it's this one, right? You go from this here and you go to this. So it really depends what information you start with. And finally, when you're done solving this quadratic equation, always check your answers mathematically or in terms of the context of the question, all right?